Okay, welcome back to your favorite pre-calculus class. We're going to take a look at systems, so more than one equation, systems of nonlinear equations. If you notice this first one, you do have a linear here, but see these x squared minus y squared equals 5. This is actually a hyperbola. We haven't learned about hyperbolas yet. You'll learn that in your next pre-calculus class. But we're going to go ahead and solve these algebraically, and we'll also take a look at it visually as well, just to give you an idea of what that algebraic solution means. So what you want to do when you're solving these problems is you want to determine, do I want to use substitution, that algebraic approach, or do I want to use elimination? Well, if you're looking at this, hopefully you notice that this y is already solved for. You already got y equals x minus 5. So substitution would be a really nice one to use. Whoops, what just happened? Let me go back. Since you got that x minus 5 is already solved for. So we're going to use substitution. This is nice when you have a variable easily solved for. So we're going to use substitution. You got y equals x minus 5. We're going to substitute into this x squared minus y squared equals 5. So since y is equal to x minus 5, I'm going to plug that in for y right there. So I have x squared minus y squared equals 5. Again, y is x minus 5. And then I'm going to go ahead and expand this. FOIL that out, first outer inner last. So you got x squared minus, I got x squared minus 5x minus 5x, so minus 10x plus 25 equals 5. Then go ahead and take that minus through. Notice the x squareds cancel, so we got 10x minus 25 equals 5. We're just solving this for x. So we'll go ahead and add 25 both sides. We get 10x equals 30. 30 divided by 10. And so we get x equals 3. So now we know x equals 3. So then the question is, which one do I plug it into? This y equals x minus 5 or the x squared minus y squared equals 5? Well, let's say we plugged it into the linear, so we get y equals negative 2. So when x is 3, y is negative 2. Remember, the solution has to satisfy both sets of equations. So let's say we had instead plugged it into the other one. X equals 3, 3 squared minus y squared equals 5. Subtract 9 on both sides. I get negative y squared equals negative 4. Divide by negative 1, I get 4. This one is proposing plus or minus 2. In other words, this x squared minus y squared equals 5 has two y values when x is 3. The linear one only has one y value. It was 3, negative 2. So remember, it's got to satisfy both, so I can't have that solution. I can only have the 3, negative 2. So this is saying that this linear, if I had graphed it, this is what it looks like. Here's your y equals x minus 5 right there. And this other one, I'll do it, let's make it in red here. This is the hyperbola. This is the x squared minus y squared equals 5. Again, I know we don't cover in this class how to graph hyperbolas, but you can go ahead and punch that into Decimal's graphing calculator, and hopefully you see they only cross right there at 3, negative 2. What the one we crossed out up here, see how this hyperbola had the point 3, 2 as well? The point was on there, so it had two y values for the same x of 3. So you got to be careful with this. The solution has to satisfy both. There's only one point that satisfies both. Let's go to this next one here. xy equals negative 2. If you're looking at this and you're trying to decide, do I want to go with substitution or elimination? Well, if I added these up, let's say I went with elimination, I would have x then the xy, then the 2y, negative 2 plus 0 is negative 2, is pretty clunky, right? Like, how are you going to get one of them to eliminate? That's not going to work. So you're like, I'm not doing elimination. Throw that out. Let's use substitution instead. Which one am I going to pick? Am I going to pick the top one, xy equals negative 2, or am I going to pick x plus 2y equals 0? I'm going to pick that x plus 2y equals 0 because I think that x is really easy to solve for. I don't have any fractions or anything. Whereas if I solve for the x on top, I'd have negative 2 over y. I don't really want to deal with that. So I'm going to do substitution. I'm going to substitute that into the other one. So I'm going to substitute into the first one, xy equals negative 2. I know x is negative 2y. I'm going to plug it in right there. Negative 2y goes in for my x. So I got negative 2y squared equals negative 2. Divide by negative 2, and I get negative 2 over negative 2 is positive 1. So it's proposing plus or minus 1 for y. Okay? So if y is 1, if I plug it into either one of these, x times y equals negative 2, x times 1 equals negative 2, I get x being negative 2. I could have also plugged it into the other one, subtracted 2, subtract 2 on both sides, and either way you get x being negative 2. When x is negative 2, y is 1, so that satisfies both of them. But we had two y values, negative 1. So again, I could plug it into either one of these. I won't have an issue. Oops, that's an x. Divide by negative 1. I get 2. X is 2. Y is negative 1. So I get negative 2, 1. And I got 2, negative 1. And we could take a look at those graphically for just a sec. We graph that first rational function, right? Y equals negative 2 over x. That's a rational function in red there. You see the red graph, and you graph the linear x equals negative 2y. In other words, y equals negative 1/2 x is the one in blue. You see how they cross right there. Those were our solutions. Negative 2, 1, and 2, negative 1. Now this one here, if we're looking at this, it's kind of difficult to solve for x or for y, right? So I'm thinking this would be a little easier with elimination. Right now, if I added it up, I'd get 3x squared, negative y squared, but I get plus a 2y squared equals 5. So I got to eliminate. So that's not working right now. I'm going to have to force it to eliminate one of the variables. So but I am going to use elimination. Well, notice the 3y squared on the bottom. If I can get the top to be a negative 3y squared, it's already a negative y squared, so I'm going to multiply it by 3. That'll get rid of my y's. So I got 3x squared minus 3y squared, 3 times 0 is 0. Bottom stays the same. And notice my y's are going to be gone. That's gone. So I got 5x squared equals 5. Divide both sides by 5. I got x squared equals 1. So I got x is plus or minus 1 on this one. Well, if x is 1, and when I plug it in, notice both of these have a y squared. So I'm going to get two y values when x is 1. Right, just for either equation. So it really doesn't matter which one I plug it into. I'm just going to plug it into the first one. I got 1 minus y squared equals 1. I could add, equals 0. Sorry, I could add y squared. So y ends up being plus or minus 1. When x is 1, y is plus or minus 1. So I got 1, 1, and I have 1, negative 1. And then I'm going to let x be negative 1. And let's go ahead and plug it into the second one this time. Again, it doesn't matter. Either one of them will give me 2 y values here. So 2 times negative 1 squared plus 3y squared equals 5. 2 times 1 is 2. Subtract 2. Divide by 3. Square root. We get plus or minus 1. So I got negative 1 plus or minus 1. So I got 1, 1, 1, negative 1. I got negative 1, 1, and negative 1, negative 1. All of those points are on both of those systems. Just want to show you the visual on those two. There's that x squared minus y squared equals 0 in green. There's the purple 2x squared plus 3y squared equals 5. And hopefully you notice there's the 1, 1. There's the 1, negative 1. They cross. So there's those 4 solutions that we had for that one. This one, if I'm looking at this, I'm thinking elimination. If I add these up, though, I get 3x squared. But notice these are not like terms. I'd have a y squared minus y. So there's no way to eliminate. You know, you want to either eliminate y squared or y, right? So I'm going to have to, if I'm going to use elimination, I'm going to have to get rid of my x squareds. So notice the bottom one is 2x squared. I need the top one to be negative 2x squared. And by the way, you can use substitution. If you did use substitution, I would solve the bottom one for y. But this would be probably a little easier. Negative 2x squared minus 2y squared equals negative 20. Bottom would stay the same. 2x squared minus y. Again, just be careful. Those are not like terms. Notice those are gone. So I've got negative 2y squared minus y equals negative 21. I'm solving a quadratic, so let me get one side equal to 0. So I got 0 equals 2y squared plus y minus 21. Let's go ahead and factor that. Let's see, that would be 73, I think. Yeah, plus and minus there. So I get 2y plus 7 equals 0. Subtract 7, divide by 2, divide by 2. So I get negative 7 halves. And y minus 3 equals 0. So I got y equaling 3. Okay. Now, let's go ahead and use the y. So this was step 1. I did my elimination. I found my y values. Step 2, or potential y values, I should say. Step 2 is, all right, who am I going to throw it into? If I throw y in to either the top or the bottom, notice I have x squareds here and x squareds there. So it's going to spit out 2 x values, regardless of who I plug it into. Okay, so let's go ahead and let's pick the bottom one here initially. So step 2 does this one. I just want to make sure, does it satisfy both equations? So we get 2x squared minus a negative 7 halves equals negative 1. 2x squared plus 7 halves equals negative 1. That subtracts 7 halves. So negative 2 over 2 minus 7 over 2 is negative 9 over 2. Divide by 2. I got negative 9/4. Now let's think about that for a minute. Will I ever have an x value when it's squared give me a negative 9/4? Hopefully you say, no, that doesn't work. Not in the real numbers, right? This would be plus minus 3i over 2. We're not working in the imaginary numbers for this. We're staying in the real numbers. So I'm just going to throw out negative 7 halves. Okay. Now, this is why I say be careful. Had I thrown this negative 7/2 in, remember it's got to satisfy both. Had I thrown it into this one, x squared plus negative 7/2 squared equals 10, would it have given me a solution? X squared plus, that's a plus 49 over 4 equals 10. Subtract 49 over 4. X squared equals 40 over 4 minus, yeah, it still gives me that. So yeah, either one it would have not worked for. Okay. Sometimes it'll work for one, not the other. It's got to work for both, right? It's got to work for both. So toss this out either way. Negative 7/2. You are worthless. So let's keep going on. Y equaling 3. Plug it in. 2x squared minus y is negative 1. Add 3. Negative 1 plus 3 is 2. Divide by 2. Square root. I get plus or minus 1. So plus or minus 1, 3. Make sure you check the other one. It does work on both of those. And here's a graph on that. You know, the first one, you've got a circle with a radius of square root of 10. So that radius is like 3 point something. You see it in black there. The second one, if you were to solve that for y, you've got a quadratic. Y equals, what's that, 2x squared plus 1 in red there. So hopefully you can see that they hit right there at that 1, 3 and negative 1, 3. So 1, 3, negative 1, 3, like we have there. All right, here we've got a square root function, right? Negative root x. So it looks like the square root of x, looks like that, but it's flipped over a reflection about the x-axis, so it'll be more like that, right? And then we've got a circle that's hk, x minus h, right? Center of the circle is 3, 0, with a radius, r squared equals 5, radius of root 5. So 1, 2, 3, 0, radius of 2 point something, and 2 point something. This, so it's kind of like that type of deal. I don't know that I drew it the greatest, but anyways, you should see it hitting a couple times here. That's kind of what we're looking for, but we're just doing this thing algebraically. And I'm seeing that y equals negative root x. I'm seeing this is already solved for. I'm just going to use substitution on this. So we'll throw that into the other one. That'd be easier than elimination, no doubt. So y is negative root x. Let's throw that in for y right there. X minus 3 squared plus negative root x being squared. Well, negative root x times negative root x is a positive x. I'm going to expand this. Combine like terms. Get one side equals 0 there. So we got x squared minus 6x plus x minus 5x plus 4 equals 0. So we got minus 1 minus 4. So we got x being 1, x being 4. So step 3, if x is 1, now who am I going to plug it into? If I throw it into the circle for 1, I'm going to get 2 spots on the circle, right? So I don't want to throw it into that one. I want to throw it into the radical. It's more restrictive, if you will. It'll only spit out one y value, right? So be strategic when you're throwing this in. Be analytical and make sure you throw it into the more restrictive one, if that makes sense. Negative square root of 1. So we got negative 1. So when x is 1, y is negative 1. When x is 1, y is negative 1. There's that first point right there. And then we also said x could be 4. Y equals negative root 4. So we got y is negative 2. When x is 4, y is negative 2. So this is the point right there, 4, negative 2, where those hit. Again, don't throw it into the circle. If you'd have thrown it into the circle, it'd give you two spots where the x is 4. Right? But the solutions have to satisfy both systems of equations. This last problem, we've got kind of a funky system, and you can really clean this up if you notice that they both have over x squared and over y squared. So I put a big hint on this. Hint, go ahead and let u be 1 over x squared and v be 1 over y squared. So let's rewrite this. This is 5 times 1 over x squared minus 2 times 1 over y squared equals negative 3. This other one is 3 times 1 over x squared plus 1 times 1 over y squared equals 7. So if we replace the 1 over x squared with u and the 1 over y squared with a v, this is what we'd have. 3u for the second one plus 1v, 1 over y squared, equals 7. And now I'm looking at this and I'm like, oh, that's really nice. I could do elimination. I could do substitution too. So whatever you want to do. Yeah, I'd probably get rid of the v here, right? Go with e1, but I'd probably get rid of the v. Notice the top has a negative 2v. I want the bottom to be a positive 2v, so I'm going to multiply by 2. So this will become 6u plus 2v equals 14. Top is going to stay the same. 5u minus 2v equals negative 3. So number 1 is I'm going to let that make a substitution. And then number 2 is I'm going to use elimination down here in this case because the v's will cancel. So I got 11u equals 14 minus 3 is 11. So u equals 1. All right. So if I know if u is 1, remember u is 1 over x squared. Let me multiply both sides by x squared. So I have 1 equals x squared. In other words, x squared equals 1. So x could be plus or minus, oops, let me scroll that down, plus or minus 1 on that. So what would y be? Well, I could plug it back into either one. If x is 1, or x could be negative 1. I just got to pick either one of those originals. Let's just pick the top. So I got 5 minus 2 over y squared equals negative 3. I'm going to subtract 5. So I got negative 2 over y squared. Subtract 5, I got negative 8. Let me get my y's on top. So let me multiply both sides by y squared here. So I got negative 2 equals negative 8y squared. Divide by negative 8. So I get y squared equals negative 2 over negative 8, so 1/4. Square root both sides. So y equals plus or minus the square root of the top over the square root of the bottom. So when x is 1, y is plus or minus 1/2. 1, 1/2, 1, negative 1/2. Now when x is negative 1, again, we could plug it into either one in this case. Let's plug it into the bottom one this time. 3 over negative 1 squared plus 1 over y squared equals 7. 3 over 1. 1 over y squared equals 4. Multiply both sides by y squared. So divide both sides by 4. And it looks like y ends up being plus or minus square root of the top over the square root of the bottom. So when x is negative 1, y is 1/2. When x is negative 1, y is negative 1/2. And we've got our solution as those 4 coordinates. Thanks so much for watching and taking notes on systems of nonlinear equations. We'll see you next time.